Hello everyone, welcome to Payment Tech Media. In this video we will have more examples of default subnet mask for class A, B, and C. Let's jump into my computer and take a look. A, we have 255.0.0.0 and only 8 bits. It's for the network. And for class B, 255.255.0.0, we have only 16 bits for the network. And then class C, we have 255.255.255.0. We have 24 bits for class C. And if I write down one IP address, let's say 192.16.83.51. So if you want to know this IP address belongs to what class, looking at the first octet, and 192 falls into the class C range of IP address, which previous videos we talked about. How can we tell if this IP address belongs to class A, B, or C? And more detail we talked about. If you haven't watched those videos, please make sure to go back and watch. And the default subnet mask for this IP address, class C, 255.255.255.0. So let's write down the default subnet mask, 255.255.255.0. And this 255.255.255.0, what does it mean? Again, this 255 on the first octet. So this is the first octet, second octet, third, and the fourth. It pretty much means that we have 8 ones here. So 1, 2, 3, 4, 5, 6, 7, 8. 255, 8 ones. Pretty much ones represent network bits, zeros represent host bits. And in binary, which again in previous videos we talked about how we can convert binary to decimal, and this is the decimal notation, and here we are writing the binary notation, binary format of these decimal numbers. Okay, so 255, 8 ones, 128 plus 64, 32, 16, 8, 4. If we add all these numbers, it should be 255. And then the second octet, 255, means again we have 8 ones, and then the third octet, 255. So the third octet also all the bits turned on. The fourth octet, 0. So we have 8 zeros. That's the host bits. So ones, network bits, zeros, host bits. And when we talk about subnet mask, always goes from left to right. And it's just keep adding one after another. For example, in the following videos, you will see we will talk about classless subnet mask, borrowing bits, and so on. So from the host bits, we will borrow bits from, let's say, going from left to right, 1, 2, 3, and it's basically turning on, which we will talk about more later on. Right now, we are talking about default subnet mask or class full subnet mask. And again, for class A, 255.0.0.0, class B, this is the default subnet mask, class C, that's the default subnet mask. So this IP address, 192, that's class C IP address because 192 falls into that range, class C range. And then here, this is the default subnet mask for class C. So what does it mean? It basically tells us that the 192, so if I want to write down here, 192.16.83, that's the network. So if it was 0, that's the network address. When we have .51, that's for the host. So this 192.16.83.0, that's a network address. 192.16.83.51, that's the host IP address inside this network address. So let's take a look more in detail. So these subnet masks, basically here as we can see, for class C, we have 255.255.255.0, and here we can see this is pretty much the cut line. We have between ones and zeros. So to the left, network bits, to the right, host bits. All the ones, network, zeros, host. So the last bit that is turned on, what is the last bit that is turned on? So let's see, if we go from left to right, the last bit that is turned on is this one. The decimal value for the last bit that is turned on here is 1. That's very important information, known as block ID or network increment ID. And on what octet are we working on? Where is our basically last bit? It's on the 3rd octet. So it's basically incrementing by 1 on 3rd octet. So this is one example going over class C using default subnet mask. So I'm going to go ahead, erase, and make some space. Okay, so this is the IP address they gave us, and we can tell this is 192. So that's class C IP address because 192 falls into that range. And here we can see 255.255.255.0. That's the default subnet mask for class C IP address. Okay, so here we can see based on this default subnet mask, we have the first 3 octets for the network, the last octet for the host. 255 means 8 ones. So on the first octet, 2nd octet, and the 3rd octet, and this is the last octet, which is .0. So here we have 8 zeros for the last octet. So this is the binary format. So here is the actual decimal format for the subnet mask. So when we talk about IP version 4, is basically a combination of IP address and subnet mask. And subnet mask tells us what section of the IP address belongs to the network and what section belongs to the host. Which in this case, 192.168.1 is the network and 58 is the host. Why? Because 255.255.255, that's the first 3 octets. 0, that's the last octet. 0 means host, this 255 means network. 8 ones in binary is 255 in decimal. So 1s represents the network bits and 0s represents the host bits. Okay, so let's write down the network address, which also we do have the ANDing formula. It's basically if we convert the IP address and the subnet mask to the binary and then apply the ANDing formula, and the result, that's the network address. So to show you guys, if we write down this IP address, if we convert this IP address to binary, so 192, it's basically 128 plus 64, that's 192. The rest of the bits, it's off. So let's write down, we have 192, so that's 1, 2, and then we have 6 zeros because in every octet we have 8 bits, so that's 2 so far. 1, 2, 3, 4, 5, 6. And then 168 decimal, which we can use our calculator here, as we can see. So let's use calculator. We need to change the standard view to programmer view. And then making sure decimal is selected, which it is selected. So writing down 168. 168. And here we can see the binary is 10, 10, 1000. So let's write down for 168, 10, 10, 1000. And then 1, it's only this one turned on, right? Of course, on the 3rd octet here, 1. So pretty much we have 7 zeros and only 1 1. And then on the last octet, 58. So which of these decimal values do we have to add in order to get 58? Or we can just quickly use our calculator. So making sure decimal selected, 58, and in binary 0 0. So let's write down 0 0 1 1, and then 1 0 1 0 1 0 1 0. Okay, next is writing down the actual subnet mask in binary format. So this 255, it pretty much means 8 ones. And it has to be aligned with this because when we apply the ANDing, not to make any mistake, this 25581s and this 25581s and then this 0 for the subnet mask. This is the last octet 0, so it's 8 zeros. Okay, now if we want to apply the ANDing, which is basically the only time the result is 1 if both of them turned on, the IP address and the subnet mask bit turned on. That's the only time the result is on. So this is on, so that's on, that's on. This is off, on, so that's off, on, off, off. Pretty much the rest of them it's off because here we can see 1, 2, 3, 4, 5, 6, 7, and 8. Here 1, 1, that's on. Let me put dots. On. This is off because again the only time it's on if both of them turned on. So this is off, on, that's off, on, that's on. Okay, so again both of them should be on. This is off and this is both of them on, so that's on. And here 1, 2, 3, all of them it's pretty much off. So because again the only time the result is on, the actual IP address, the binary format, the bits, and the subnet mask, the binary format, the bits, both of them should be on. So here we can see this is off, and on. So when we apply the ANDing formula, 0, 1, that's 0, 0, 1, that's 0, 0, 1, that's 0. Both of them should be on in order for the result to be on. And alright, then here all of them it's pretty much off. Only the last one, both of them it's on. So we have 7 zeros. 1, 2, 3, 4, 5, 6, 7. The last one turned on. And here it seems that pretty much all of them it's turned off. 1, 2, 3, 4, 5, 6, 7, 8. Because again, every octet we have 8 bits. And here we can see 1, 2, 3, 4, 5, 6, 7, 8. So anytime when we have the IP address and the subnet mask, when we convert the IP address and the subnet mask to the binary format, and when we apply the ANDing formula, which again the actual bits for the IP address and the subnet mask, if it's on, the result is on. That's the only time the result will be on, if both of them it's on. Now this is our network address. Basically this IP address belongs to that network address. So when we convert this to decimal, which this one is 192, this one is 168, this one is 1, this one is 0. So this is the network address for this IP address. In other words, we talked about earlier that when we see IP address, first looking at the first octet, we can tell what class this is. In this case 192, that's class C, and the default subnet mask for class C is 255.255.255.0. So this 255.255.255, that's the network portion, network bits. 0 is the host bits, right? The host portion. So the network portion, 255.255.255, 192.168.1, 192.168.1. And 0, that's the host, right? So we put 0. So that is the network address. In other words, here, this was an example of using ANDing formula to get the network address, or we can just simply use the subnet mask and the cut line. So these 255, how many bits are they? 24 bits. If we count here, this is 8 bits plus 8 bits, that's 16, plus another 8 bits, that's 24, and then this is our cut line. To the left, these are the network bits, ones, network bits, zeros, host bits. And the last bit that is turned on, that's known as network increments or block ID, so which is by 1 on a third octet. Therefore, it's telling us next network, it's incrementing by 1 on a third octet. So for example, the next network would be 192.168.2.0. You see how this is 1 on a third octet, so we are here. This is on a third octet, first, second, third. This is on a third octet incrementing by 1. Why by 1? The last bit that is turned on, it's this one. So the decimal value for the last bit that is turned on, that's a network increment or the block ID. It's giving us information that what will be the next network. So the next network will be 2. And what will be the next one? 192.168.3.0 and so on. It's incrementing by 1. So, but this IP address that they gave us, 192.168.1.58, falls into the first network, because here we can see 192.168.1, 192.168.1.0. And okay, let's go ahead. We don't need this calculator. We can close. Let's close that. And if we want to go over the range, so this is our network address, and we have broadcast address. So the broadcast address is the last IP address. It's basically one before the next one. And in this case, 192.168.2.0. So this one, if you want to write down the broadcast address, before, let me quickly show you guys. You know how in decimal value we have 0, 1, 2, 3, so on, so on. When we get to 9, what happens? It basically turns to, after 9, it's 10, right? So this 9 turns to 0 and adds to the 10th place 1, correct? So we say 10. And then we have 11, 12, so on, so on, so on. When we get to 19, what happens when we get to 19? So basically this 9 turns to 0 and then adds to the 10th place 1, so it's a 2, 20, 20, correct? So kind of same applies here when we talk about this basically octets, all that. So for example, you see how here is 2.0. So what is the maximum, the last value in one octet? The range goes from 0 to 255. If we add one IP address, what happens? It turns to 0 and adds to the, basically to the left side octet, which is, here we can see 2. Therefore, for this network address 192.168.1.0, the broadcast address, the last IP address, basically, for that network is 192.168. Or it is 1.255. If we add one IP address to this one, what happens? It's not 256. So that turns to 0 and then adds to this place. So 256, that's not correct. It turns to 0 and adds to this 2.0. So here we can see 2.0. Okay, now we have our network address that representing this network. And here we have the broadcast address. That basically, if a router receives a packet that the destination is this address, the router knows that I have to forward the packet to all the IP addresses in that network. So that's broadcast address, broadcast communication. Broadcast communication means that one to any undefined numbers of devices, basically. All of them, depending, some of them are turned on, some are turned on, doesn't matter. So it says to all, that's a broadcasting. Like let's say radio channels, the broadcast channel, right? And then we do have a multicast, which previously we talked about, which class we talked about A, B, and C. That's mainly where we have this subnet mask. And then D, it's a multicast address, and E for scientific and research purposes. So this class D, as David, class D, it's a multicast address. Multicast address, it means that one to many groups, defined groups of basically devices. We can think of like XM radio. XM radio is like based on subscriptions. You have the subscription, you are part of the network, you can receive the multicast sessions. But the broadcast means anyone out there can receive this communication. So if a router receives a packet with the IP header destination address of 192.168.1.255, the router will forward basically that packet to any IP addresses in this range, which we will go over. So what is the first usable? By the way, this range in this parentheses, it's known as usable IP addresses. So this network address and the broadcast address we cannot use, we cannot assign them to the computers because it's used by applications, the routing protocols, routers, and so on. We cannot use and assign this IP address to an interface or to, let's say, a computer or printer, network print device. We cannot. It's mainly used by applications, routing protocols, and so on. So that's why we will do -2. We will talk about the formula and so on, but let's go ahead and talk about the available range for this network. So 192.168.1.1, that's the first available IP address. 192.168.1.1 to 192.168. goes from 1.1 less than the broadcast address 254. So 1.1 to 1.254, how many available IP addresses are they? 254. There's a formula if we want to find out the number of hosts equals 2 to the power of host bits minus 2. Why minus 2? Because of the network address and the broadcast address. We cannot use them, we cannot assign them to the devices on the network. It's mainly used by the programs and the applications, routing protocols and all that. So these are the usable IP addresses in this range. Let's see how many host bits do we have. 1, 2, 3, 4, 5, 6, 7, 8. Therefore, 2 to the power of 8 minus 2. So that's 256 minus 2, 254. So 254 available IP addresses we have for class C. Therefore, looking at this IP address 192.168.1.58, this is an example of an IP address in this network. This is the network address 192.168.1.0. That's a network address. So this 1.58 should be in this range, 1.1 to 1.254. What we did, they gave us this IP address. We looked at the first octet here, and we realized the 192, that's class C, and default subnet mask for class C, 255.255.255.0. These are the network bits, the host bits, and here we can see our network increment, the last bit that is turned on. This is the decimal value, that's the network increment, and here incrementing by 1 on the third octet because the last bit turned on is on the third octet. So in the default subnet mask for class C, we have 254 available IP addresses, a total of 256 IP address. Depending on the question scenario, if they ask how many usable or available IP addresses, it's 254 usable or 254 available IP addresses. If they say what's the total of IP address, we need to include the network and the broadcast. The total is pretty much 256. But the usable, the available that we can assign to the interfaces, to the basically host, computers, network printers, devices on the network, these are the available IP addresses. Now, if we take a look on the next network, 192.168.2.0, it's pretty much exactly the same. So what is the broadcast? The broadcast is one less than next one. So 3.0, it will be 2.255. So 192.168.2.255. If we add one IP address, it will be 2.256. We don't have 256, right? It will be 0 and add to the left octet, add 1. So it will be 3.0. And all right, so what's the range? So it will be 2.1 to 2.254. Let's write down 192.168. This is 2, right? 2.1 That's the first available IP address, and the range goes to 192.168.254. If we add one IP address, it will be 255, which is the broadcast address. So remember, these addresses here, these are pretty much all these addresses are the network address, and these addresses here, broadcast address. Broadcast address. So these addresses here, broadcast address, these addresses here, network address, and these addresses here, all the available IP addresses, ranges basically. Okay, so in this network 2.0, 2.255, the broadcast, the network address, and the available IP addresses. Now, any IP address in this range, they can ping, they can communicate, talk together, they are on the same class, same network. For example, if I write down, let's say 192.168.1.1, so let's write down 192.168.1. Let's say 8. Let's write down another IP address, 192.168.1. Let's say 19. Another IP address, 192.168.1. Let's say 116. So all these IP addresses, based on its default subnet mask 255.255.255.0, they are on the same network, and they can ping simply just being connected to switch. They can talk together, they can communicate, and but if you have another IP address, let's say 192.168.2.18, so that's 2.1 to 2.254, that's on this network. So this is on different network. All of them same class, class C, but this one, it's not on the same network as these three IP addresses, because remember, class C is 255.255.255.0. So the first three is network, and the last one is the host, right? So the first three must match. 192, 168, 168.1, this is 2. It's not matched in the first three. So we know this one is on a different network. In the next video, we will go over more examples of Class C default subnet mask. I hope this video was helpful. If you liked the video, please hit the thumbs up. If you want to see more tech videos like this, please make sure to subscribe to our channel. Thank you so much for watching, and have a good day.